In this video, I'm going to show you how to implement tree traversal algorithms using recursion. So we're going to do a pre-order traversal on this tree. In which order are we going to visit these nodes? We're going to do root, left, and then right. Now here's the interesting part. Both the left and right nodes are subtrees. So when we get to the left node, we forget about all the other nodes in this tree. We imagine this subtree is the only tree in the world that we want to traverse. How are we going to traverse this? Once again, we start at the root, then we go to the left, and then right. Now here we have a small subtree with only 3 nodes at 2 levels, but this subtree could be very large. Again, every time we get to the left node, we focus on that subtree. So we're breaking down a large, complex problem into a bunch of smaller and easier to solve problems. This is where we use recursion. So we're going to create a method. This method should have a parameter, and that parameter should be the root of a tree to traverse. When we want to visit the left or right nodes, we're going to recursively call that method. Let me show you. We're going to use the same tree we built earlier in this section. If you want to code along with me, you can download this main class as well as the tree class we've built so far. I've attached these two as a zip file below this video. So we're going to implement pre-order traversal. That is pretty easy. We add a new method, public void traverse pre-order. We give it a node parameter called root. Now in this method, first we want to visit the root, which means we're going to print its value on the console. Then we're going to visit the left and right children. Now, when visiting the left and right children, we're going to recursively call this method itself. Let's see how it works. So first we're going to visit the root node, which means we're going to print it on the console, root.value. Next, we're going to recursively call this method. And as an argument, we're going to pass root.leftChild. And similarly, we're going to call traverse preorder and give it root.rightChild. So now we have a recursive method. But this recursive method is missing a base condition. We need that condition to avoid a cycle. What is that condition? As we traverse this tree to the left, we get to this node. This node doesn't have a left or a right child. So when we recursively call our traverse method, we're going to give it null as an argument. If we pass null to this method, this line is going to throw an exception, a null pointer exception. So here we should check for null. If root equals null, we want to return. We don't want to do anything. And this is exactly our base condition. The moment we get to this point, that means we should stop going forward, we should go back. So this is how we can implement pre-order traversal on a tree. As we can see, it's fairly easy. The only complex part is recursion, which I hope you understand at this point. But if not, don't worry, we're going to have lots of examples of recursion in this section. So let's test this new method. Back to the main class. After we populate this tree, we're going to call tree.traverse preorder. Now here we need to pass the root node of this tree, but this root node is declared as private. So what are we going to do here? Well, we got to go back to our tree class and overload this method, but without a parameter. Let me show you. So public void traverse preorder with the exact same spelling. But here we're not going to have a parameter. This is the method that we're going to call from outside of this class. In this method, we're going to kick off the traversal. So we call traverse preorder and pass the root node. Now we're not going to call this method from the outside. This will become implementation detail. So we'll make this private. So from the outside, we simply work with this method. In this implementation, we are using recursion, but tomorrow we may change this implementation and decide to implement traversal using iteration, using a loop. If we change the implementation, the code outside of this class is not going to get affected. Okay, so back to the main class. Now the error is gone. Let's run the program. And here are the numbers on the console, 7, 4, 1, 6, 9, 8, and 10. Now as an exercise, I want you to pause the video and implement the other depth order traversals on your own. So you should implement in order and post order traversal. All right, here's my solution. So we have 2 traverse in order methods. One is public that we call from the outside. The other is private, which is implementation detail. The implementation of this method is very similar to the pre-order traversal method. The only difference is in the order of these lines. So when we do in-order traversal, we visit left, then root, and then right. That is the only difference. And here's my post-order traversal methods.